We move out of the modes and into the op-amp parameters. We're going to look at several op-amp parameters listed in the objectives, then also popular IC op-amps compared in terms of these parameters. So if you take a look here, we've got several: input offset, input bias, input resistance, input offset current, output resistance. So there's several here. We're just going to kind of go through these so you have an idea that they exist. Um, the idea would be for you to go back, read through these carefully, and make sure you have an understanding of them. The input offset voltage, VOS, the ideal op amp produces 0 volts out for 0 volts in. In a practical op amp, however, a small DC voltage, V out, they call the error, appears at the output when no differential input voltage is applied. Its primary cause is a slight mismatch of the base emitter voltages of the differential input stage of an op amp. The input offset voltage drift, then with temperature, as with any and all semiconductors, temperature is a big factor in dealing with especially these types of components, integrated circuits. The input offset voltage drift is a parameter related to the offset voltage that specifies how much change occurs in the input offset voltage for each degree change of temperature. Typical values range anywhere from 5 microvolts per degree Celsius to about 50 microvolts per degree Celsius. Usually an op amp with a higher nominal value of input offset voltage exhibits a higher drift. Extremely low drift op amps are available for precision applications that have input offset drift for less than 2/100ths of a microvolt per degree Celsius. Input bias current, I bias. You've seen that the input terminals of a diff amp are the transistor bases, and therefore the input currents are the base currents. The input bias current is the direct current required by the inputs of the amplifier to properly operate the first stage. By definition, the input bias current is the average of both input currents and is calculated as follows. So you can see here that we've got the bias, two currents input, 1 and 2, and we cut them in half. The concept of input bias current then is illustrated in section 1811. Actually, it's figure 1811 to the right. The input resistance Rn, there are two basic ways to specify the input resistance of an op amp, are differential and common mode. The differential input resistance is the total resistance Rn differential between the inverting and non-inverting inputs as illustrated in 1812A. So 1812A to the left. The differential resistance is measured by determining the change in bias current for a given change in differential input voltage. The common mode input resistance is the resistance Rn between each input and ground and is measured by determining the change in bias current for a given change in common mode input voltage as depicted in 1812B. Input offset voltage IOS. Ideally, the two input bias voltages are equal and thus their difference is 0. In a practical op amp, however, the bias currents are not exactly equal. The input offset current is the difference of the input bias currents expressed as an absolute value. Actual magnitudes of offset current are usually at least an order of magnitude 10 times less than the bias current. In many applications, the offset current can be neglected. However, high gain, high input resistance amplifiers should have as little IOS as possible because the difference in currents through the large input resistances develops as a substantial offset voltage. Look at the diagram below. The offset voltage developed by the input offset current then is as given. So V offset is equal to IOS Rin. The error created by IOS is amplified by the gain AV of the top op amp and appears in the output then as V out as the error. So it's the gain times the offset current by Rn. The change in offset current with temperature affects the error voltage. Values of temperature coefficient then for the offset current in the range of a half a nanoamp per degree are common. So when we come back, we'll take a look at output resistance.